Welcome back with a new video on reactivity series of metals. Here we will be discussing metals reacting with water, acids and oxygen, metal displacement reactions, rusting of iron, oxidation and reduction. Before going into it, let's see the reactivity series. The order of reactivity of metals can be deduced by making experimental observations of reactions between metals and water, acids and oxygen. The more vigorous the reaction is, the metal will be at the higher position. The less reactive, it will be at the bottom of the reactivity series. Now, just by reacting a metal with water or acid or oxygen individually cannot help us to find out the exact position of the element in the reactivity series. We need to have a combination of reactions, and on that basis we can plot the elements in the reactivity series. Please send cats, monkeys and cute zebras into hot countries. Signed, Jordan. This is just a funny phrase. You can have your own phrase to understand the reactivity series. Temperature change in a reaction can also be used to determine the order of reactivity. The greater the temperature change in a reaction involving a metal, the more reactive the metal. See over here, carbon is placed between aluminium and zinc. It can reduce zinc oxides to zinc, but it cannot reduce aluminium oxides to aluminium. Whereas hydrogen is placed as it helps in the reactions of metals with water and acids. I hope the reactivity series is clear. Now let's get on to our first topic, that is metals reacting with water. We have a reactivity series for our reference towards the right hand side. Potassium, sodium, calcium, these react violently, vigorously with water to give away hydrogen gas and metal hydroxides. If a small piece of, say, potassium or sodium is placed on the surface of water, the heat produced is enough to melt the metal. Magnesium reacts slowly in cold water, but a strong reaction is obtained if the steam is passed over heated magnesium to form magnesium oxides. So let's see. Potassium, it reacts with water to give potassium hydroxide and hydrogen gas is evolved. Sodium reacts with cold water to give sodium hydroxide and hydrogen. Calcium also reacts with water to give calcium hydroxide and hydrogen. These reactions are exothermic as they give out heat. Now, as we go on to magnesium, aluminium and the rest, that means all the metals below calcium, they do not react with cold water, or they react very slowly with cold water, but they react with steam to form metal oxides. Magnesium, it reacts with steam to give magnesium oxide and hydrogen gas. Now you can see over here, this is liquid as it is cold water, but over here it is gas as it is steam. Down the reactivity series, copper, silver, gold, they do not react. Metals react with acids and oxygen. Firstly, we will see metals reacting with dilute acids, and later we will see how metals react with oxygen. So all the metals above hydrogen, that is potassium, sodium, calcium, magnesium, aluminium, zinc and iron, these react vigorously with dilute acids, whereas copper, silver, gold, they do not react with dilute acids. The metals which are more reactive, you have to be very careful while doing these experiments because they are dangerous, they could be explosive too. So you have to take precautions when you are doing these experiments. Now when a metal reacts with acid, it forms a salt and hydrogen gas is evolved. Metals reacting with oxygen, potassium, sodium, calcium, magnesium, these react readily with oxygen to form metal oxides. Aluminium when it reacts with oxygen, it forms aluminum oxide. This is a thin layer. This thin layer stops the reaction between aluminium and oxygen. Due to this, the reaction slows down. Due to this, it is below magnesium. So this is how we have to consider things when you are talking about reactivity series. Whereas copper, silver, gold, magnesium reacts with dilute sulfuric acid or say with dilute HCl, they form salt and hydrogen gas. Similarly, they form salt and hydrogen gas. So magnesium reacting with dilute sulfuric acid will give magnesium sulfate plus hydrogen. Similarly, zinc and iron will also give zinc sulfate and iron sulfate respectively. Magnesium reacts with dilute HCl to give magnesium chloride, salt and hydrogen. Similarly, zinc will give zinc chloride and iron will give iron chloride. Reaction with oxygen, copper will react with oxygen to give copper oxides. Let's have a recap of all the reactions of how metal reacts with water, acids and oxygen. Metal with water gives metal hydroxide and hydrogen gas. Metal plus dilute acid gives salt and hydrogen, whereas metal when it reacts with oxygen, it gives metal oxide. The next topic, metal displacement reaction. Metal displacement reaction is a reaction in which a more reactive element displaces a less reactive element from a solution of its salt. The displacement reaction in a solution helps us to compare directly the reactivity of two metals, and it helps to establish the order of reactivity series. Displacement reaction can be done in two ways. One is reacting a metal with a metal oxide by heating, and the other one is reacting a metal with an aqueous solution of a metal compound. So let's see the first one, that is metal with metal oxides by heating. Reacting a metal with a metal oxide by heating, magnesium reacts with a metal oxide to give magnesium oxide plus copper. Here we can see that magnesium is highly reactive compared to that of copper. We can see it in the reactivity series over here. Magnesium is highly reactive than copper, thus magnesium will displace copper and form magnesium oxide plus copper. Now if I have copper plus magnesium oxide, will this reaction take place? Let's see. We know that magnesium is highly reactive than copper. So will copper be able to replace magnesium? No. Why? Because copper has less reactivity compared to that of magnesium. So in this case there will be no reaction. Reacting a metal with an aqueous solution of a metal compound. Over here too, The more reactive metal displaces the less reactive metal from the solution of its salt. So zinc will replace copper from copper sulfate to form zinc sulfate plus copper. Let's see the experiment. We have copper sulfate that is blue in color and a piece of zinc. Dip the piece of zinc in copper, leave it for some time. After some time you will see that there are some coating of copper on zinc and the solution has become colorless. This shows us that zinc replaces copper to form zinc sulfate and copper atoms. We can see over here in detail we have sulfates on both the sides. They do not participate in the reactions, they are not changing, they are the same. That's why these are known as spectator ions. Zinc, highly reactive, is replacing copper ion and forming zinc sulfate plus copper atoms. So since the spectator ions are being cancelled off, finally we have zinc plus copper ions in the reactants, while zinc ions plus copper in the product. So the more reactive metal is slowly displacing copper, so the blue color changes to colorless. Rusting of iron. When iron reacts with water and oxygen, it forms hydrated iron 3 oxide. This iron 3 oxide hydrated is known as rust. It is a red brown powder. Over time, holes are formed in iron objects by continuous rusting process. Over here, water and oxygen is very important. If water and oxygen are not present, then iron will not rust. A point to be noted over here is only iron and steel are rusting. Other metals too break down, but they are known as corrosion. They are not called as rusting. Because of rusting, the object starts to deteriorate. Now, how can we preserve the deterioration of the object? That can be done with the help of barrier methods. These barrier methods, they help in prevention of iron or steel objects. There are different types of barrier methods. Let's start with the first one. Painting. As we all know, we usually use this in all our iron objects. This is an easy method and commonly being used everywhere. We can see painting of chairs, gates, bridges, ships. These paint layers, they help in protecting iron from we can repaint it the moment the paint fades or it comes out. Next, oil and greasing. These are being done in the parts of machinery so that the machinery work efficiently without getting rusted for a longer period of time. Plastic coating. We usually see this on our refrigerators, pins. Then there are garden chairs where these plastic coatings, they help the iron objects from getting rusted. If these plastics break off, then iron will start rusting. Electroplating. Electroplating is a process where an iron or steel object can be electroplated with a layer of chromium or tin to protect rusting. Again, if the protective layer is broken, the steel beneath will begin to rust. Galvanizing. Galvanizing is a process in which the iron object is coated with a more reactive metal like zinc Here, even if zinc is corroded, it will not allow iron to rust. It will protect iron from rusting, whereas in the previous methods, the moment the barrier methods were damaged, iron started rusting. But over here it won't. This is being used in Ebesto sacrificial protection. Here blocks of a reactive metal are attached to the iron surface, like zinc, magnesium blocks are attached to oil rigs and hulks of ship. These are blocks of either zinc or magnesium. They are attached to the iron body of the ship. Being highly reactive, then iron, zinc or magnesium will corrode, that is, they sacrifice themselves so that iron does not rust. Underground gas pipes, water pipes also use these barrier methods to protect themselves. The more reactive metal oxides more readily than iron, so it sacrifices itself, while iron does not rust. Zinc will corrode to form zinc ions plus electrons. These electrons can be used by iron to protect itself from rusting. Thus, iron will become safe while zinc will corrode itself. Let's come to our last topic of the video, that is oxidation and reduction. Oxidation and reduction are two processes which take place simultaneously, therefore they are also known as redox reactions. Redox reactions can be in terms of oxygen or in terms of electrons. Let's start with oxygen. Oxidation is a process where the element gains oxygen, while reduction is a process where the salt loses oxygen to form an atom. Now zinc is gaining oxygen to form zinc oxide, thus this is an oxidation reaction. While copper oxide is giving away oxygen to form an atom, this process is known as reduction. Copper oxide is giving away oxygen so that zinc can oxidize. That's why copper oxide is an oxidizing agent, while zinc is oxidizing by taking in oxygen. So zinc is a reducing agent. Now, since these both reactions are happening simultaneously, that's why we called it a redox reaction. Oxidation and reduction in terms of electrons. An atom gives away electrons to form positive ions. The less reactive element will accept this electron to form an atom. So an atom got converted into positive ions, and ions, negative, got converted into atom. So this process of an atom giving away, losing away electrons is known as oxidation, and an ion in the salt, in the compound, accepts this electrons to form an atom. This process is known as reduction. So from this we come to know that the one which is donating electrons is a higher reactive metal, and the one which is accepting these electrons is a less reactive metal. Let's take an example of it. Magnesium plus copper sulfate gives magnesium sulfate plus copper. Magnesium will give away 2 electrons to form ions, and these 2 electrons are being used by copper in the copper sulfate solution to give away copper. So Here we have two equations. Magnesium is losing electrons to copper in copper sulfate, so this is oxidation, while copper is receiving electrons to become an atom. This is reduction. So magnesium became a reducing agent since it is helping in reduction, while became an oxidizing agent. Oxidation is the loss of electrons, reduction is the gain of electrons. I hope it's clear. Redox reaction in terms of electrons: oxidation, oil, reduction, Reg. Oil, oxidation is loss of electrons, Reg is reduction, is gain of electrons. This is an easy way to remember. Summary: the different levels of reactivity are based on how the metal reacts with water, oxygen and dilute acids. The elements of group 1 are the most reactive metals at the top of the series. Transition metals are more moderately reactive. Metals like copper, silver, gold do not react with water or dilute HCl, thus placed on the bottom of the series. A more reactive metal displaces a less reactive metal from a solution of its salts. The position of a metal in the series is related to the tendency of the metal to form its positive ion in reactions. Metal displacement reactions are redox. Rusting of iron and steel requires the presence of oxygen and water. It increases with the presence of salts or acid rain. Corrosion of iron and steel is a major problem, and various methods have been devised for rust protection. Barrier methods of rust prevention are painting, oiling, greasing, coating with plastic. Galvanizing is an object by coating with zinc is both a barrier method and protection even if zinc layer is broken. Sacrificial protection is a form of rust protection using blocks of a more reactive metal attached to an iron or steel structure. Electrons are lost from the more reactive metal to the iron or steel to prevent the formation of iron oxide. Oxidation can be defined as the gain of oxygen by an element or compound, while reduction is loss of oxygen during chemical reaction. Oxidation can be defined as loss of electron, while reduction is gain of electrons during chemical reactions. An oxidizing agent will lose the oxygen or gain electrons during the redox reaction. A reducing agent will gain the oxygen or lose electrons during the redox reaction. Redox reactions involve simultaneous oxidation and reduction. Thank you.